Hi, I'm Ayse Bagbaba from High Performance Computing Center of Stuttgart. I'm part of Expertise Project Workpackage 4 High Performance Computing for Structural Dynamics. I will talk about I/O optimization in HPC and present our results. I/O is commonly used by scientific applications to achieve goals like storing numerical output, loading initial conditions, and checkpointing. Applications deal with large data sets, and data access is a huge challenge because of scalability limitation of I/O. So I/O becomes probably the most limiting factor. There is no one-size-fits-all solution to the I/O problems, so parallel I/O is an essential part of these applications. A typical parallel I/O stack offers a number of tunable parameters that can achieve the best possible I/O performance. However, finding good configurations of an I/O application is often challenging because engineers have no time or experience for exploring the right combination of these parameters for each problem. So when a configuration space gets larger, it becomes difficult to monitor the interactions between the configuration options. In most cases, the default settings are implemented, often leading to poor I/O efficiency. We propose a predictive performance modeling-based parallel I/O auto-tuning approach that can recommend an optimal set of parameter values, currently tested with MPI-I/O and Lustre, for an application on a given system. Because the model uses an I/O prediction to determine these values instead of running the application, it can significantly reduce execution time and resource usage. It hides the complexity of I/O stack layers from developers. We have validated our model using two I/O benchmarks, IOR and MPI tile I/O, and the Molecular Dynamics Simulation Program LS1 Mardin. Using the model, we achieve an increase in I/O bandwidth of up to 18 over the default parameters for collective I/O in IOR benchmark, 5 over bandwidth for non-contiguous I/O in MPI tile I/O benchmark. We got up to 32 improvements for 16 billion particles in LS1 Martin checkpoint writing. As a conclusion, we presented a predictive modeling-based I/O auto-tuning approach to tune the parallel I/O stack parameters. We also presented a performance model to estimate I/O performance based on the results of the previous runs. And we demonstrate that our approach can indeed be useful for auto-tuning in HPC. For any benchmark or I/O application, our model can be trained with negligible effort. That's it. Thank you.